Welcome to the Math Record. Today I'll be covering the ICTM State 2013 Division A Algebra 1. I'll be going through every single question and I'll also be timestamping it as usual. Okay, number 1. A certain number is 5 more than 90% of 90. Find the value of that number. So 90% of 90 is just 9/10 of 90, and since it's 5 more, just add a 5. So cancel out the 10 to make a 9, 9 to 9, 81, plus a 5, 86. And that's your answer. I prefer to usually work on number 1 by hand. Usually it's simple, so you could do it with a calculator, but it's kind of slower. Okay, number 2. There are 7 sections of seats in an auditorium. Each section contains more than 150 seats and less than 201 seats, which the following could be the number of seats. Okay, so there's 7 sections and each section has the amount of seats. So it has to be more than 150, so it could have 151 as its minimum, and less than 201, so maximum is 200. And there's 7 of each, so just multiply each of them by 7. So that would be 300, 1057, and this one is going to be 1400. Okay, so the number between them is D, and that is your answer. Okay, it should be simple. You could probably just do that on your calculator also. Number 3, the slope of a line that contains P, 5K, and 8W is 3. Find the value of W minus K. Okay, so W minus K, which is just slope, over 8 minus 5 is equal to 3. So W minus K, 8 minus 5 is 3. 3 times 3 is 9. So W minus K is 9. And that's basically it. Number 4. In the town of Johnson Village, there are 2,329 females and 2,055 males. The fractional part of the total of the females and males that are male can be expressed as K over W. Find K plus W. Okay, so male over the total, which is 2055 plus 2329. We just do this in your calculator. 2055 plus 2329, and then divide it, and you should get 15 over 32. Adding these two numbers together, that is 47. And that's your answer for number 4. Okay, number 5. You have purchased an item and paid $39.06, which include a 5% sales tax. The cost of the item before the sales tax was added was, okay, so the 39.06, that is a 5% markup. So then you have to have 1.05, 5% increase from 100 times the original price, which I could call x, to get 39.06. So to get x, you just divide the two numbers, 39.06 divided by 1.05, to get 37.2, which is answer A. Okay, and number 6. For all real numbers x, let the operator x, this kind of operator, equals x plus 2 if x is equal to even, and that same operator is 2x minus 1 if x is odd. Let the dot of operator equals x minus 1 based on these definitions. Okay, so now we have a 7, which is an odd, so we have to use this one. So 2 times 7 is 14 minus 1 is 13. And the dot of operator of 4 is 4 minus 1, which is 3, is equal to the dot operator of k. So that's just k minus 1. So that's 39. Add that 1 to make the 40 for your k. And that is your answer for number 6. Okay, just plug everything in and it should be simple. Two cartons have respective weights of 6x minus 31 and 3x plus 10 pounds. If the average weight is 66, the heavier carton weighs how many more pounds than the lighter carton? Okay, so to calculate the average, it's just total over um, the amount of cartons. So there's 2 cartons and this is the total weight, and that is 66 pounds. So doing some math, that's 9x minus 21 is equal to 132. So 9x equals 153. So x equals 153 over 9. Okay, and then they said they want to find the difference. How many more pounds is the heavier than the lighter? So we could just subtract these two. So 6x minus 3x is 3x. Negative 31 minus 10 is minus 41. And we don't know if it's positive or negative, so just stick an absolute value in there. And then we just plug in x and do it in our calculator. So 153 divided by 9 times 3 minus 41 is equal to 10. And that's our answer for number 7. So usually you like to do all the math and then not really simplify, and then you can just plug it all in your calculator. It saves time and it's really effective. Number 8. For two quadratic polynomials px and qx, px plus qx equals 7x squared plus 3x plus 1, and px minus qx equals 3x squared plus 7x minus 5. The polynomial qx is ax squared plus bx plus c. Find a, b, c. Okay, so I noticed that this one, it's a p plus the q is equal to 7x plus 3x, 7x squared plus 3x plus 1. And the p minus the q equals 3x squared plus 7x minus 5. So we want to get the q, we just need to make this the negative, this one the positive. So just multiply each side by -1. So that's a negative, and this turns into a positive. Add them together, that's 2q, 4x squared minus 4x, and plus a 6. And then we divide by 2 to get our q, which is 2x squared minus 2x plus 3. So ABC is 2, -2, 3. And that is our answer for number 8. Number 9. The intercepts of the graph of y equals x squared minus 2x plus k are 6 units apart. Find k. Okay, so if we have a x-intercept at a, the other one will be a plus 6 because it's 6 units apart. So in that form, we could write it as x minus a in intercept form. So we have x minus a plus 6, right? So we have these two. And now we could distribute it out. So that's x squared minus 2a plus 6x plus a times a plus x, a plus 6. So that would be the same equation as x squared minus 2x given in our question plus the k. So we know the 2 is equal to a 2a plus 6. So 2 minus 6 is -4. -4 divided by 2 is -2. So -2 equals a. Plug it into this to get our k. So that would be -2. -2 plus 6 is 4. So -2 times 4 is -8. And that is our answer for number 9. Number 10. If ax plus ac plus dx plus dc equals 12 and a plus d equals 4, find the value of x plus c. Okay, so what I noticed is that we could kind of distribute out the, we could factor out like some common values. So from here we could take out the a, and from here we could take out the d. So a, that's x plus c, and then plus take out the d, which is x plus c. And then I noticed that there's two x plus c's, so we could combine a plus d together, a plus d, and then multiply it by the x plus c. And that's equal to 12. So we know a plus d from the question is 4, so this is 4. So x plus c, which is what we're looking for, is just 12 divided by the 4, which is 3. And that's your answer for number 10. So you really don't need to find the values, and you probably can't. But what you could do is that you can manipulate your variables around and solve it. And that was your first 10, and they're all pretty kind of basic. Number 11. Find the value of x such that 4 over x minus 3 plus 1 over x plus 3 equals 8 over x squared minus 9. So we have 4 over x minus 3 plus 1 over x plus 3 and 8. And x squared minus 9 is just x plus 3 and x minus 3. So what we do is to get the same denominator. So right here we have to multiply by x plus 3. So that's 4x plus 3 plus x plus 3 here. So we need x minus 3. And then this one doesn't need anything because it already has it. So usually I don't have to write the bottom portion because they're already all equal. So it's the same thing. So we just need to set our numerators equal to each other. So that's 4x plus this x is 5x. This is 12 minus then 3, which is plus 9 is equal to 8. So 5x is equal to negative 1, so x equals negative 0.2. And what you usually want to do is that if you have an answer, you want to see if it actually works with the denominator. If x was equal to 3 or negative 3, the bottom is going to be 0 and it's going to be undefined. So you got to make sure that it's true. But this isn't, so this is the answer, negative 0.2. Okay. Number 12, find the value of base x if 24 base x divided by 30 base x equals 3 base x and 4 base x. Right answer in base 10. Okay, so when you're working with numbers with bases, basically the terms from the right to the left goes from constant, linear, quadratic, etc. So let's say we have 1, 2, 3, 4, 5, etc. It doesn't really matter. I just put in this order because I can't think of any numbers right now. So this would be our constant, so it would be 5. Our linear is 4, so 4 times 6. Our quadratic is 3, so it's 3 times 6 squared. And then our cubic is 2, so it's 2 times 6 cubed, right? So we get this as our bases, and these are just the coefficients, which is found out from this number. And that's basically it. So all we have to do is look at this number, which is 24 base x, so it's just 4, plus the linear times 2, the 2. And then on the bottom is the same thing, so it's 0 plus 3 times x. And this one is just 3 and this is 4. So now we could cross multiply, so we get 16 plus 8x is equal to 9x. So our 16 is equal to our x, and we already solved it because this is base 10 already. So that is our answer. 12 is 16. 13. Given that 4x squared plus kx minus 36 with one factor of 2x minus 4, find the value of k. So if you kind of think about it, we have 4x squared plus kx minus 36, oops, sorry, divided by 2x minus 4. That should come out as some kind of equation, and we call that f of x. Okay, so what we could do basically now is that if we plug in, right, because this is a number, we could rewrite this as f of x times the 2x minus 4. So now if we plug in a value for x, let's say x is equal to 2, right? That's 4 minus 4, that's 0. So f of 2 times 0 is just 0. And then you plug in here, times 2 squared plus k times 2 minus 36 should equal 0. So that's 4, that's 16. 16 plus 2k minus 36 equals 0. So that's minus 20. So 2k equals 20 on this side because it's positive. So that makes it 10. And that's your answer for number 13. But an easier way to do this without doing all this work, which is the same process, is that if you see the 2x minus 4, just set it equal to the 0, the factor equal to 0, and then solve it, which you get 2, and then plug in that number to your original equation. And it should be equal to, that should give you the value of your k, and you have to also set that one equal to 0. There's a specific property you might have learned, theorem, which works with this is called the remainder theorem, which I just said. Number 14, assume that the stocks are only priced in tenths with no rounding, for example, 23.7, 23.8, 23.9, etc. Um, between April 1 of 2008 and April 1 of 2009, stock X traded in the range of greater than 62 and 71. Okay, so they gave us dates, so let's kind of make like a timeline. So let's say this right here and this right here. And this is April 1st, 2008. And this is April 1st of 2009. Okay, and they tell us that stock X is between 62 and 71. Okay, so let me rewrite this a little bit neater. 71. Okay, not the best handwriting. On April 2, 2008, so somewhere right here. Okay, stock X traded at 3/4 the price of stock W. So stock X at this time, so let's call that X subscript 1, so at the beginning, is equal to 3/4 the price of stock W at that time. Okay, now on March 31st, 2009, the price of stock W was zero point 0.1 lower than it has been on April 2nd, 2008. Okay, so now we're on March 31st. So March is before April, and it's at the 2009, so it's right here. And we have the price of stock W at that time, which is W, would say is 0.1 lower than it's been on April 2008. So there's two W's. There's the current value at March 31st, and there's a W value, which is at April the 2nd. So this is W2 and that one's W1, so don't confuse them. And that is equal to, it's 0.1 lower than it's been on this value. So it's W1 minus 0.1. Okay, and the price of stock X on this date, so we'll call that X2, and was 2/3 the price of stock W at that time. So 2W2. So we had to find the price of stock X on this date. So we need to find X2. Okay, so what we would do is that we could rewrite everything into that equation. So let's have this equation as 4/3 of X1 is equal to W1. So we could plug this one into here. So W2 is equal to 4/3 of X1 minus 0.1. Okay, that's good. And now we have W2, which we could plug in here. So we have X2 is equal to 2/3 of 4/3 of X1 minus 0.1, which I'll just write as 1/10, since everything's already in a fraction. And we have to look for X2. Okay, so now we don't need the timeline anymore, and we just need to solve this equation. So remember, we have some bounds. We have X. So X2 and X1, they're all X's. They have to be between our range, which is 62 and 71 that they said in the beginning. And it has to be in tenths, so 62.1, 62.2, 62.3, etc. All the way into like 69.9, because that's below 71, just below it. So what we could do now is we could distribute this out. So we have x squared equals, actually, let's first simplify this one. So a 3 and a 10, that's least common multiple of 30. So we need to multiply by 10 on this one, so that's 40 times x1. Actually, let me write the 2/3 first. 40 times x1 minus 3 of here over 30. So this is the same thing as just this. Okay, so what we do now is that we could multiply the 2 and the 2/3 into this number. So x squared is equal, cancel the 2 here, makes a 15. So we get a 40 times x1 minus 3 all over 15 times 3, which is 45. Okay, I'll put this here and write our bounds again. 62 between x is between 62 and 71. This is important because now we have this number and we have to find the value of this, which is really difficult because then we have to do a bunch of trial and error, which takes forever. So to limit the amount of possibilities, we got to look at this value. So they said that it has to be in tenths. So what is 45 made of? It's made out of 5 and 9, which is also kind of like threes, right? So it's 5, 9s, and 3s. So if you divide a number by 3, it's going to either be 0.3 repeating, 0.6 repeating, or it's going to be 1. So, or like remainder basically. So this doesn't work because these are repeating and they have said it's only no rounding, so this doesn't work. But the 3 kind of works sometimes at the 1, but that works for every single one. Now 0.9, it will be like a 0.1 repeating, 0.2 repeating, 0.3 repeating, etc. into 1, right? And 5 is 0.2, 0.4, 0.4, 0.6, 0.8, and 1, right? So they show that every single one doesn't really matter. So we don't have to think about the 3 and we don't have to think about the 9 because they all have like some number repeating. So it's gonna round. So but they said no rounding. So the only one we could work with is a 5. So what this tells us is that from the 45, we need to take away our 9 somehow. So what we could do, let me erase all of this. Let's split up our 45 into a 5 and a 9. And now we need to take away our 9. So to do that, we need to divide it out. So we have a 3 here, but there's no 3 here. So what we could do is that we could change our bounds. So we could say x1 is equal to like some 3 times a. Okay, so x is between 62 and 71, right? So a is now between 62 divided by 3 and 71 divided by 3. Okay, so now we can substitute x3 3a into x1. So that would be 40 times 3a minus 3 over 5 times 9. So we could cancel out one of the 3's from 9 and cancel out this 3 and this 3. So we have 40a minus 1 over 3. Okay, so we have this number. So, 5 times 3. So what we could do now, we don't need this bounds anymore. And we're working with this number. And we need to cancel out this 3 now, but we don't have a 3 in here anymore. So we had to make this 3 happen. So we could change our bound yet again and say a is equal to some bound, let's say a new variable 3. But remember, it has to have a 3 multiple. So, but now we have a 40 in front of it, right? So let's say to make this into a 3 multiple, we got to add something to it. So let's say it's a minus, so we keep track with the minus. So we have some kind of constant. So this constant, we got to think about it. So it's a 1 plus a 40, that's 41. That's not divisible by 3. Okay, the next one is 80. 80 plus 1, 81 divided by 3, that's possible. So we got get the second multiple, right? So a equals 3b minus 2, and we can substitute that in. And now let's change your bounds yet again. So it's 3b minus 2. So you could just use our calculator to do this. And you could just kind of do some rounding. So 62 point divide by 3 plus a 2 and then divide by 3. And we should get a 68 over 9, or you could just round some decimals. But I'll be precise since I'm solving this right now. And we have 71 divided by 3 plus 2 divided by 3. And we have 77 over 9. And we get our range for B. So what we have here, we could plug it in. So that's 40 times 3b minus 2 minus 1 over 5 times 3. And that is also simplified as 40 times 3b minus, this is the 8, this makes 80, plus the 1 is minus 81 over 5 times 3. And we cancel out the 3 here, and this one becomes a 27. Okay, so now we basically have what we could solve for. So remember, this is x2. So x2, which is what we're looking for, is 40 times b minus 27 over our 5. So now we have everything, because all the numbers here are always going to be some kind of value of 0.2, 0.4, etc. 0.2, 0.4, 0.6, and 0.8. So it's a tenth without any rounding. And we know our bounds is between 68, 9 and 71, 77, 9. Okay, so let's convert these into fractions to see what they look like. So we have, because remember, our numbers for our b has to be kind of in the tenths, because our x2, right? Our x1 is equal to 3a, and our a is equal to 3b minus 2. So technically, our x1, plugging a into here, we have 9b minus 6. So for this to be a tenth in the point tenths, like let's say a 63.5, right? For it to be a point 0.5 and not like a 0.56, etc., that means b has to only be in the tenths also. So we could just find out some numbers for b. So we have 68 divided by 9. And that is a 7.5, well, 7.6 because it's 7.55 7.5 repeating, so 7.6 is the lower bound for B. And then 77 divided by 9, and that's a 8.5 repeating, so the upper bound is 8.5. Okay, so all the numbers less than or equal to. So the numbers we could test are 7.6, 7.7, 7.8, 7.9, 8, 8.1, 8.2, 8.3, 8.4, and 8.5. So if we want to find a value, let's just start with the biggest one and then work our way down. Because since this is the upper bound, if the lower bound is the number, and since we're kind of scaling it, basically the numbers might not be between 62 and 71. So let's start with the biggest number possible, because then it might be possible. So we have 8.5 times 40 minus 27 divided by 5. And you should get a value that is 62.6. Okay, so that one works. Now we have 8.4. So we could try at 8.4. So 40 times 8.4 minus the 27 divided by 5, and we get a 61.8. So remember, our range for x has to be between 62 and 71. This is outside that range, so it doesn't work. So that tells us that this doesn't work. And since all the numbers is getting smaller, all these don't work also. So the only one works is the 8.5, which gives us our x value of 62.6. So that is our answer for number 14. So number 14 is pretty long. I recommend you probably not try to solve it because it also takes a lot of logic to think through. Number 15. The sum of the digits of a three-digit number is 16. So let's say our digit number is ABC, hundreds place, tens place, ones place. And the sum of it is A plus B plus C is equal to 16. The hundred digit is 1/3 the tenths, so A equals 1/3 B. And in the units digit is 4 times the hundreds. So the unit digit is 4 times the hundreds. So now let's put everything in A. So A plus B equals 3A, and C equals 4A. So that's 1 plus 3 plus 4, so that's 8. So 16 divided by 8 is 2, so A equals 2. And now we need to find the number of ABC, so we just need to plug it all into these values. So that means B is equal to 3, 6, and C is now equal to our 8. So it's 2, 6, 8 because it's ABC. So that's our answer, 268. Should be pretty simple. Number 16. One of the roots for x of the quadratic equation x squared minus 2x plus k is 1 minus square root k square 10. Find the value of k. So we have x minus 1 minus square root 10, right? That's one of the roots. So for it to simplify without a radical, what we could do is that we could use this conjugate. So it's x minus, keep this one the same, so it's 1, but make the negative to a positive. So now instead of negative 10, we have positive 10. Positive square 10. So we multiply them together, that's x squared. Distribute them out. And then minus, so that's a minus. The 1 plus 1 equals 2. Negative square root 10 plus square root 10 is cancel each other out. So this is just minus 2x. And this is positive. 1 times 1 is 1. 1 square root 10, 1 negative square root 10 cancel out. And negative square root 10 times positive square root 10 is minus 10. So that gives us 9. So our k is equal to 9. So that's our answer. Negative 9. 1 minus 10 equals negative 9. Okay, and that's your answer for number 16. Number 17. Find the minimum value of the expression x plus y plus z. Okay, so we need to minimize this. Okay, and we're restricted by the function 8x plus y plus 12z and equals 62. So what we do here is that we could think about some numbers. We have an 8 and a 1 and a 12 as our coefficient. So if you think about it, if we want to minimize x plus y plus z, we need to get as much of these numbers up as possible. So if we put like one value for here, that takes away 12 to 62 slots, if you think about it. And while if we put 1 here, we take away 8 out of the 62. So we want to put more into the higher values than the lower values because the lower values would take up more room, thus these numbers will increase, but this number would kind of like slowly go down. So what we do is that we want to put more numbers in z and x than to y. So let's say what's the maximum value for z? If we put 5, that's 60, that's pretty close, and we can't get higher than 5. We can't put we could put a 5 here, a 2 here, and a 0 here. But they said they're all positive integers, so this doesn't work because 0 is not positive. So the next number is 4. That's 48. So we have left is 14, so we could put 1 here and 6 here, which is the maximum possible. Um, and then the next one we put 3, which is 36. So we have 26 left over, which could put 3 here, so that's 24. So we have 2 left over here. Okay, so this is a total of 11. This is a total of 8. Let's go to the next one, 2. So this is 24. Then this is going to be 38. And this one, you could put a 4. So that's 32. So that leaves a 6 left over here. So that makes it 12. So you see that it just got bigger. It's got smaller and then got bigger. So it's probably going to get bigger again. So this one is going to be 8. Because if this is going smaller each time, then this one has to go bigger. So, or this one goes bigger, which is not going to work because 8 and the 12 kind of interchanges, but this one increased way more than this one's decreasing. So we have the smallest value is 8 because that's 3 plus 2 plus 3. And that's your answer for number 17. It's just a bunch of trial and error, but it shouldn't take too long. Number 18. A bag has 1 red and 3 blue marbles. You take out 2 marbles at the same time. Find the probability that they're the same color. Since only blue has multiple of them, then we can only take into account blue. So taking 2 marbles, 3 blues, choose 2 of them. And then out of the total is there's 4 marbles and you choose 2 of them. So that's 3 factorial, 1 factorial, 2 factorial, 4 factorial, 2 factorial, 2 factorial. So we have the 2 factorial here, cancel with this one. So we have a 3 factorial, and then we have a 4 factorial, and then 2 factorial back on top. And the 1 factorial is just 1. So we have a 3, and then, sorry. And then 3 factorial, 4 factorial leaves the 4 on the bottom with the 2 factorial on top. 2 factorial is just 2, so 2 over 4 is equal to 1/2. Or you could just put them all in your calculator, and it's just about the same way. Number 19. A line contains points A, B, C. If the equation of the line is 2x plus y equals k, and the coordinates of A, B, C are 2a, b, -2, 1, 4, respectively, find the sum a plus b. So we know 2x plus y is the equation. So the slope is going to be -2 because if you move the move it to -2x plus k equals y, then our slope equals -2. Right? Self-explanatory. So we could just use 2 points of each. So let's use the first two. So -2 minus a, then b minus 2 is equal to -2, right? And then we have 4 minus, use the first and the third. We have 4 minus a, and then 1 minus 2, which is -1, is equal to -2. So using this equation first, because there's only one variable, we have 2, and then 4 minus 2 equals 2. So a equals 2. Now we can plug it into this one. So that's -4 over b minus 2 equals -2. And then we can switch places. So -4 divided by -2 is 2 equals b minus 2. So b equals 4. So we have 2 plus 4 to get a plus b, and that equals 6. And that's your answer for number 19. Okay, so simple manipulation of variables. 20. Find the largest integer that divides 300, 417, and 664 with the remainder r1, r2, r3, respectively, such that r2 equals r1 plus 3 and r3 equals r2 plus 5. So we have 3 numbers and we need to divide it by some kind of integer. So it's 300 times is equal to some kind of constant, we'll call it a, times I, which is our integer, plus our remainder. And we do the same thing for every single other number, so 417. Now this is a different constant, plus R2. And we have 764 equals C times I plus R3. So A way to think about it would be like, why do I write it in this form? Because let's say we have like a number like, let's say 30. If we're dividing it by, let's say 7, right? What's 30 divided by 7? What's the integer? Well, that's going to be a 4 remainder 2. So we have a 4 times a 7 plus 2, right? So our 4 would be the a, the 7 would be our integer, our I, and our remainder would be 2. So that's 20 plus 2 is 30. And that is the basic principle for this. So what we could do now is that we have R2, R1, R2, and R3. We need to get the same remainder. So we know R2 equals R1 plus 3, so R1 plus 3. And we know R3 is R2 plus 5. But R2, which they already gave us, is R1 plus 3. So that gives us that 300, which we could keep the same. And then 417 is equal to BI. Well, let's do some math here. So there's a 3 here, so subtract the 3. So 414 equals BI plus R1. And we have a 5 plus a 3 here, that's 8. So minus the 8, so 756. And that is equal to CI plus C times I plus R1. And I'll just write this again. 300 equals A times I plus R1. Okay, so how do we get rid of the remainders? So what we could do is we could subtract each of the 3 numbers by another number. So let's move this here. So we could subtract, usually I like to keep the numbers positive, so I'm going to subtract 414 by 300, so that's 114. And the remainders cancel each other out, and BI minus AI equals B minus A times I. Okay, now let's do the third number and the first number. So subtract them, that is 456, and that is C minus AI times I, right, in parentheses. And then we could do the second and the third, so that covers all of them. So that is 342, and that is equal to C minus B times I. So now we have to think about this kind of logically. So why do I do all this? Well, the reason is because if we look at these numbers, we have 114 equals some kind of difference times an integer, right? So if we have a number and we had to divide 114 divided by b minus a to get an integer, what that tells us is that I is a factor of 114 and b minus a is also a factor of 114. So if we want to find I, basically, is that we have to find factors of 114, and we do the same thing with this. If this is not this, and we are looking with the second equation, we have 456 divided by c minus a equals I. I is now a factor of 456. So what we need to do is that we need to look for factors of this, this, and this. And then any factors that are the same, that is going to give us our greatest integer that could divide into the 3 numbers. So there's multiple, and that's why it has this equation. But what we had to do is we had to look for the largest. So we would just use our calculator to factor these numbers. So factor 114, and that gets 2 times 3 times 19. Factor 456, which is 2 to the power of 3 times 19. And then we have to factor 342, which gets 2 times 3 squared times 19. So they each have a 2, they each have a 3, and they each have a 19. And then we just multiply them together, and that is 114, which is coincidentally this number. So that is the largest integer that divides into those 3 with the same, well, um, which gives us these properties. So your answer is 114, and that's basically it. Well, that completes everything. So overall, this year was kind of challenging-ish. We have questions 20 and questions 14, which would take a while. But then they have some basic questions like slope, probability, optimization, and then and then the quadratics, and then just some logic ones like 15 and like 10 and like 9. And then we could just work, and then there's the usual base change, and the in the basic questions would have a specific operator, like some averages, and more probability, and basically basic arithmetic. Well, thanks for watching, and I'll see you at the next math record.